Hi everyone! In this video I'm going to discuss a K-means and agglomerative clustering implementation. This is part of a project that I developed in the time of Datathon, and it's called City Search Tool using machine learning algorithms. So the main idea of this is to find a place or a city that suits you according to your priorities and personality. So basically, to develop a tool that just can help you to make a decision in terms of moving to another country or city in this case. For this, we use four main databases: Move Hub City Ratings, World City Population, Cost of Living Index, and Weather. So each one of them provide information related to specific cities. This is the workflow that we use and decided to implement. So the first step was just to do the load and exploration of data, a little bit of data mining and analysis. Then the visualization of the data. We use histograms, correlation matrix, scatter plots, matplots, and bar charts. Then we did the preprocessing, just the cleaning, the preparation, the manipulation of features. We also perform transformations in the data, such as power transform and robust scalar. And finally, we basically perform the clustering. We use K-means and agglomerative clustering for this. So this is the first step, the data load and preprocessing. For this, we kind of follow the same workflow on each database. So here we loaded the data. Then we decided to do a little bit of the analysis of the data. We tried to observe if there was any missing values, if there were duplicates, if the type of data was accurate. So we did this basically for all of the databases. We followed the same workflow. And then what we did is that we merged all of these databases that we had. So that's what we did. Again, we dropped some of the rows that didn't provide any useful information. We checked the duplicated data, and then we just basically concatenated all of our databases. Again, just this is a little bit about the preprocessing, and then we just obtain the final database. That is basically this one that you see here. And then after this, we did the visualization of the data. So we basically use PyPlot because we wanted to basically implement a very interactive tool. So this is a little bit about all of the cities that were included in our database. And each one of these cities provides their specific characteristics in terms of the features that we decided to include, such as purchase power, healthcare, quality of life, pollution. So we basically did that and obtained this cool map. So like this, we can basically observe the overall distribution of our data. Then we decided to do a little bit of data visualization for different features. So for this, we use a bar plot, and we decided again to use PyPlot for this. And we decided to color this type of data based on another feature. So in this case, use population, and the colors were associated with the pollution. So that would give us an idea of how our data was distributed, and just to understand if there was any important pattern in the data. So this is the top 20 cities and with the highest population, and then they were colored with the pollution. We also constructed a pie chart just to understand the distribution. So for this case, we can observe that Tokyo is basically the city that has the highest population, and you can observe that it provides a high percentage on this pie chart. And then we also did a scatter plot using two features, just in order to again to observe any pattern in data. And again, we use PyPlot for this, just because we wanted to also understand a little bit of the features associated with that specific city. So this is again crime rate versus the quality of life, using the quality of life in our color bar. We did that for again for the scatter plot, and we basically try to just understand our data using visualizations, tons of visualizations. So again, this is quality of life versus disposable income, since we noticed that there was a potential relationship between both features. So again, here just to understand if there was any pattern in the data. Pollution, the distribution associated with the highest pollution. And then after this, after all of this visualization, we decided to implement clustering. Remember that for clustering, we only have the features or predictors. We don't really have any label or response associated with that specific data. So here we just decided to do some pre-processing in terms of understanding what was categorical and what was numerical here. And just to observe all of our features and predictors. And here I plotted basically all of the features to try to observe if there was any correlation between each feature, just basically understand if there was any multicollinearity. We plotted here the correlation matrix, again to observe if there was any potential multicollinearity between features. Here, we computed the variance inflation factor for the multicollinearity analysis. We decided to plot the histograms because we also wanted to observe if we had a Gaussian distribution in each one of our predictors or features. And then after this, after all of this analysis, we decided to only choose the ones that were uncorrelated. And then we constructed a final correlation matrix with our final features. And these are just the features that display a relatively low correlation. We did the pre-processing after doing the before doing the clustering. We decided to do some power transformation to obtain a better Gaussian distribution. For this, population was not included, so don't worry about this. Again, this is just after the transformation that we perform. We did robust scalar just to obtain the same with the same scale to obtain the same scale data. Again, we didn't choose population. And then after this, that we obtained all of these, we basically apply all of these transformation. We decided to apply K-means in the uncorrelated features. We plotted the elbow plot to understand what was the optimal number of cluster. However, it was difficult for this type of data since it didn't display that a very clear elbow plot point. We also plotted the silhouette plot and calculated the silhouette scoring here. So here we can observe for this type of features, I believe that is the quality of life and crime rating. Here to observe what was the silhouette score for each for different number of clusters. So in this case, we decided to choose 5 clusters. This is just a very naive implementation. This can be much better for sure, so don't worry much about the results. So that's basically what we did. We applied 5 clusters for this type of data, and then we decided to plot our results using different predictors just to see if we could find any pattern. So for instance, we can observe that here there is a very clear pattern in terms of the crime rating and quality of life for this type of cluster. Same here, it seems that there is a very clear cluster in terms of the healthcare in the average disposable income. So we did this for many of the predictors just to see if it was actually displaying something powerful. We also decided to display all of these clusters on a map, on a map plot, just to observe if maybe there's also a relationship or a pattern in terms of the locations. And it seems that there was some patterns, some useful patterns here in USA, here in Europe. So that was pretty useful. Again, this is just a little bit the final results that we got. We used the same map plot that we display at the beginning, just to show all of the cities and their specific clusters here. And with this, you can actually go and see, hey, this is all of the cities that display some of these common characteristics or features. So in order to compare it and to understand if we obtain a good clustering, I decided to also apply agglomerative clustering. So in here we basically decided to calculate our dendrogram just to try to grab and to understand what was the best number of clusters for this. We used 5 number of clusters since the main objective was to compare with the k-means, and we basically apply the same features for this. And we did found that same trends in terms of clusters, which was good. Just that means that that's how the data is just distributed. So again, we found very useful clusters here for crime rate and quality of life. Again, the pattern is very similar to the K-means one. And this is just the healthcare and disposable income here. We can see a clear trend here. We did that again for other features, and then we decided again to plot this in a map just to observe if there was any relationship. Again, some of these clusters were in common, but it was not 100%, or even, I don't say, like maybe 90% equal to the k-means. But this is just the implementation that I wanted to show, not really the results of it. So this is again the PyPlot implementation, the map plot that I use for all of the clusters here. So thank you so much. If you have any questions, just comment. All of these codes and Jupyter notebooks can be found in a GitHub repository. So if you need to get a look on the implementation of this, go ahead. Thank you so much.